Our learning objective for today is I can calculate the probability of compound events using multiple representation. Let's start from here. When do you multiply your probabilities and when do you add? What is the keyword? In the last video, I have discussed to you about how are we going to identify the three types of compound probability events. So, two of those needs to be multiplied in order to get the probability, while one of those needs to be added to get the probability. So what's the keyword? So when you say multiply, that means you can use that one for independent events and dependent events and dependent events. So you are going to multiply the probabilities of each event in order for you to get the total possible outcomes, that is based on that what is the desired outcomes. So what about the other type of probability? You need to add for the mutually exclusive events. And what are those keywords? So the keyword for the mutually exclusive event is the word or. While here, the keywords are, it can be the word and, or it can be the word at the same time. So, at the same time. Or you can also have while. So, there are still a lot of words that will be the keyword, but these are the most common, especially the word and the word or. So let's have the first example. Trey is spinning the spinner on the right 2 times. But this one here, this is it's down here, not on the right. So what is the probability that Trey will land on green on the first spin and purple on the second spin? If you're going to analyze the problem, it is an independent probability. Why? Because if you will spin this spinner the second time around, the number of possibilities for each color or yeah will not change. There will still be 5 different colors, even no matter how many times you will spin this spinner if you will use the same spinner. So these are independent events. So if you will spin this 2 times, the probability that it will land on green in the first spin is 1 out of 5. So let's write that down, 1 out of 5, that it will land on green. And the second spin, what is the probability that it will land on a purple? So that's another 1 out of 5. So how are you going to find the probability that it will land on green the first spin and it will be on the purple in the second spin? So you simply just have to multiply this because these are independent events, right? So what's the keyword there? The word and is our keyword. So 1 times 1 is 1 and 5 times 5 is 25. So out of 25 spins, you only have one chance of getting one first on green and second on purple. Okay, out of not 25 spins but 25 tries, that means each try has 2 spins, first green, the next purple. So that is our first example. Our next example is, what is the probability that you will land on a quadrilateral and then a brown figure? So what's our keyword then? And then a brown figure. So is this independent first? Is this independent, dependent, or mutually exclusive? This is still an independent event because since you are using the same spinner, even if you will spin this one a number of times, the number of or the figures that are inside this spinner will never change. And the chances for each of the figure to be chosen or for this arrow to land on will never change. So this is an independent event. So what is the probability that we land on a quadrilateral? Let's see. How many quadrilaterals are there? 1, 2, 3, and 4. So your chance of getting quadrilateral is 4 out of 5. And the chance of getting a brown figure, so look at the colors, the brown is only 1, and that is 1 out of 5. Since we are talking about a quadrilateral and then a brown figure, so that means this is a compound event and an independent compound event. So that means you have to multiply this two in order for you to find out the probability of getting a quadrilateral first and then a brown figure next. So that is 4 out of 25. Can you reduce that one? No. So therefore, out of 25 tries, you get 4 chances of getting a quadrilateral on the first spin and a brown figure in the second spin. Our third example is, what is the probability that you will land on a number divisible by 4 or an odd number? Take note of the word or. What do you know about this word? That means it is a mutually exclusive event. So that means these two things cannot happen at the same time. A number divisible by 4, which is only 4, or an odd number. What are the odd numbers here? 1 and 3 are odd numbers. So it cannot land on 4, 1, and 3 at the same time because you only have one arrow here. But the word or indicates that it can be, I will consider if you will land on 1, it will be considered if you will land on 3, it will be considered if you will land on 4. Those are your favorable outcomes. So first, number that is divisible by 4 is only 1 out of 4 because there are 4 numbers here or 4 parts of the spinner. And the number that are odd numbers is 2 out of 4. Now, how are you going to find the probability? Since this is a mutually exclusive event and that doesn't happen at the same time, you just add them. In adding fractions, you have to make sure that the denominators are the same, or we call them similar fractions, and write the common denominator. In this case, they are similar, so no problems with the denominator. And then since they are similar fractions, you can just add the numerators right away. And that is equal to 3 out of 4. So you have 3 chances of getting a number that is divisible by 4 or an odd number if you will spin that spinner, right? So our fourth example is, what is the probability that you will land on red or green? Red or green. If you will look at the figure does not give you, or the colors are not in equal parts. But that doesn't matter because you only have 3 colors in there. So chances are the probability that you will land on red is 2 out of 4 because if you will divide this into 4 equal parts, you have 2 bigger chances of getting a red than this 2. So let's make it equal or fair for the other colors. 2 chances of getting a red out of 4. Or green. The green has only 1 out of 4. Now, what is the operation that we're going to use? Are we going to add or multiply them? What is your keyword? Your keyword is the word or. That's the word or will indicate what is the operation that you will be using. So since we have found out that this is a mutually exclusive event, then we're going to add them. And our chances of getting a land that it will land on red or green is 3 times out of 4. Okay, does it make sense? Okay, now let's proceed to the next figure. Or the next example. The fifth example is, if you flip a coin 3 times in a row, you flip a coin three times in a row. Then, using the chart at the right, how many times do you expect to have a coin land on tails, tails, and head? So this is tails, tails, and head. Remember that you flip the coin 3 times in a row. That is one chance. That is your setting. So you have recorded every time you throw the dice. After three times you throwing, I mean, of flipping the coin, you recorded how many times these things happen. How many times you have a tails, 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 head, tails, head, head, or head, head, head. So these are the number of times, 9. How many trials did you do it? That's 5 plus 9 is 14, plus 6 is 20, and plus 4 is 24. So out of 24, your chances, or you expect to have 9 out of 24. Is that your final answer? Not yet, because you can actually reduce this one by dividing both numbers by 3. So 3 is our greatest common factor for 9 and 24. So that is 3 out of 8. Now this is your final answer. Out of 8 times, your chances of getting tails, tails, and head is 3 times. Next example, probably our last one. You flip the coin and roll a die at the same time. So you have 2 different types of things that you are doing at the same time. So what is the probability of getting an outcome with heads on the coin? So never mind this table here. I don't want you to think about that. That table is from the last presentation. That is not part of this question anymore. So what is the probability of getting an outcome with heads on the coin? So remember that if you will get a head on the coin, your probability is 1 out of 2. And the probability, while at the same time on the die, you will have, let's lay out a table here. So the die will have 1, head 1, and then head 2, and then head 3, and then head 4. So these are your possible outcomes if you roll a dice and flip the coin at the same time. Head 5 and head 6. While what if you will get a tail while you flip the coin? So that means you can get a tail and a 1 on the die. You can get a tail and a 2 on the die. You can get a tail and a 3 on the die. You can get a tail and a 4 on the die. You can get a tail and 5 on the die, or you can get a tail and 6 on the die. So that means T represents tails and H represents heads. So that means how many possible outcomes are in there? So there are 1, 2, 3, 4, 5, 6, 12 possible outcomes. So, and what is the probability of getting an outcome with heads on the coin? So how many times? 6 out of 12, therefore it's 1/2. 6 out of 12, or 1/2 is your probability of getting an outcome with heads. That's for the first question. What about getting an outcome with a 4 on the die? So getting an outcome with a 4 on the die means that this is not, that there's no 4 in the die here, there's no 4 in the die here, and there are only 2 possible outcomes with a 4 on the die. So that means you only have 2 out of 12 possibilities, or total possible outcomes, or you can reduce that one into 1/6. Okay? Follow-up question. What is the probability of getting a number less than 3, for example? A number less than 3, so that's 1 and 2. So the probability of getting whatever is the thing for the head and the tail, so the probability of getting a number less than 3, I'm going to shade it this time. The probability of getting a number less than 3 is 4 times. Then that is 4 out of 12. But remember to always reduce your answer into smallest term, and that is 1 out of 3. So your probability of getting a number that is less than 3 is 1/3, right? So that is the end of our lesson for today, and hope you have a great rest of your day.